of the program. Shorthand version in the sense how, say for example, you want to do some addition. You want to do some addition in some particular program where the program is of just simply a welcome message. In that welcome message, you are keeping something like, am I audible? Yes, Rituja, Prashant, am I audible? Naveen, Vishwajit, Pranali. Okay.
Yes,
If any,
ma'am.
do tell me if any disturbance is there. Please, I mean, tell me in the sense, inform me meanwhile. Okay. If anything goes wrong. Okay. So in the last class, we have studied not studied. I have just told only the glimpse of the previous class. In the previous class, I just directly took the example how a macro can do. But before that, once again, let us recall, refresh our memory what we have studied in the C programming. I hope you all have studied some pre-processing statements in your previous classes, lower semester classes. Pre-processing statements, and also along with the pre-processing statements, in that it was mentioned that there were something like three kinds of pre-processing statements. Those pre-processing statements were something like macro processors. Or shall I ask you people? Can you answer? What were the pre-processing statements? Anybody? If you know, can you tell? Pre-processing statements, something like macro processor, file inclusion, and compiler control directives. Macroprocessor pre-processing statements, file inclusion pre-processing statements, and also the compiler control directives. But let us not worry about the file inclusion pre-processing directives and also the compiler control directives, because those file inclusion, everything, different types of file in a pre-processor of the file inclusion like stdio.h, math.h, these all things you know that very well, right? So those are called as the file inclusion header files of any particular program. But let us talk only about the C and C++ because we are more familiar with those pre-processor statements. And so these were the three. Let me write here what were the pre-processor statements. The in our lower class we have studied the pre-processor statements. There were three kinds, and the first one was the macro processor. First one was macro processor, and the second one was file inclusion. Just I'm giving you a brush up of your old memories so that which you have studied in your lower semesters. And third one was the compiler control directives. Compiler control directives. So I should write complete word saying as macro pre-processing statements. Macro pre-processing directives are the statements. And file inclusion directives. I'll write here as B. These were the three. Let us not worry about the file inclusion and the compiler control directives. Let us worry only about the macro processing or the macros directives or the macro pre-processing directives. Pre, I wrote here spelling mistake, sorry, pre-processing directives. So this is all about macro pre-processing. Now where does macro exist? Who are the macro pre-processing statements? As in the previous class told some of the students, as I told who are the pre-processing statements, like hash include, they were the pre-processing statements, and most of the students have answered also for that. And I hope I felt very happy about it. You know something about it, but how this pre-processing statements, it can be a macros and how they can be processed and what it is. Like if you go back, as we have studied in the previous class, this I have taken from my notes. I have just kept here the screen snapshot. I'll just make the slide view. Okay. So if you go back till so far, whatever we have studied about greetings on compiler, but not in detail because it is a separate chapter after macros. It is a separate chapter after macros. Well, an author should have given first beginning with the compiler only. First beginning with the compiler. But the first unit the author has mentioned as something like language processes. That is very correct. He has given. And the second unit he has mentioned something like the assemblers. Something like the assemblers. But again, the third unit he has mentioned the macro processes, and fourth unit the author has mentioned the compilers. Actually, according to our understanding of the syllabus or the understanding of the system software, everything is hidden in this compiler. We should have given first to understand about the compiler. Well, we have a separate subject about the compiler in the next semester. It is called as compiler design, because compiler cannot be covered in one lecture or two lecture, or it cannot be told in yeah, this is a compiler, like Java is a compiler, C is a compiler, or C++ is a compiler. It cannot be told because in that there are several phases of the compiler, how what it does the compiler and why it accepts the high level language. So there are several aspects to understand on the compiler. But here in this class, to go along with that, because in previous class also when I have gone with the language processor also, I have beginning with beginning from compilers, assemblers, linkers and loaders. And even I was teaching you all about the compiler, sorry, the assemblers. During that period also, I have just taken the figure of, if you remember, I have taken the figure from the second unit, uh, second unit assembler. If you remember, we have gone through this one figure, this figure. This is very important to understand whole concept of the assemblers, whole concept of the, sorry, not assemblers, whole concept of the system software. If you observe here, include header file, expand macros. This is what the macro. This is what the macro. That's what pre-processing statement. Macro is also called as pre-processing statement. Now, where this macro, what does it does? What does it does? And such pre-processing statements, what they are and what they process. I tell you, they process the source code. They process the source code. It passes through the compiler. It passes through the compiler. That is, it processes and it processes before the compiler. Now here one can tell where is compiler. Here what we are telling the compilation part. This itself is a compiler. According to the sentence, here is told as compilation of the source program. Compilation of the source program. And if you remember, why GCC and G++, these were the two types of the different versions of the commands which were used in the Linux, which were used in the Linux or the Unix tool for applying any C program compiling any C program compilation. So this depends on the different platform of the Unix or Linux. You did not worry about this. And here also one more part we have studied. We have studied Lex and Yak. In this compilation, we have studied Lex and Yak. And in this compiler, I have given the example of Lex tool, Yak tool, C, Java, C++. These all resembles for the compilers. They themselves are the big system software programs. In that, it is arranged in assemblers, loaders, and linkers. Assemblers, loaders, and linkers. Actually, here the loader figure is not given. In the next figure, it is there. In the next figure, this is what. In the next figure, this is what loader, linker, and assembler. So here, to understand about the preprocessor, whatever the source program is there, the source program is divided. The source program first begins by the preprocessor statements. The source program, your high level language, if you're going with any particular language, if you're going with any either the C, Java, C++, any different high level language, if you're going with that, so that language begins by three types of statements. It can begin by the header files or the preprocessor statements, such as the file inclusion statements, macro statements, and also the compiler control directives. So such preprocessor statements are required for a source program to have to be processed, and why they are required, how they are required, that depends on the target of the program or the task of the program. That depends on the task of the program. If suppose if I am doing only the addition of two variables, I require only the inclusion, header inclusion preprocessor statement such as stdio.h. Now, what is the file inclusion in that? The file inclusion in that, it includes the functions of the IO strings, IO stream files. Who are those IO stream files? Scanf and printf. These are the two built-in functions which are hidden or which are supplied by the stdio.h, and that stdio.h is said to be as the file inclusion system. Now, who is said to be as the macro? Macro is something like, say for example, if you want to define for, so in a program, you are doing two types of method, as in that in a program you are doing some addition method also, you are doing some multiplication also, you are doing some division also. So all four different cases you are doing arithmetic operation you are performing. So for all those arithmetic performance, assume that you want to give only one or you want to program for variables only. Say for example, only two operands are required in all of the four arithmetic operands. So in all of the four arithmetic operands, only two operands are required. So using those two operands, you're framing a small program so that it accepts those two operands, and whenever those two operands are met by add, are met by the sub, are met by the multiplication, are met by the division, they respectively perform or expand. They respectively perform or expand the program and substitute that wherever it is called. So that is called as the macro expansion or the macro. So these macro are nothing but it is something like a program, short version or the short written program in a program. So then it is nothing but a source program. It is nothing but a source program. Now one can ask why such macros has to be used. Why such macros? Macros are nothing but your shorthand version of the program, of a program. Shorthand version of a program in a program. Shorthand version of a program in a program. So those macros are nothing but a program hidden or called whenever they are they are called whenever they are required in the program. Called in the sense they expand, they substitute that full program. Suppose in a program the add uh, the add is called 4 number of times. Assume that the add is a function. It is called by 4 number of times. And it is very called 4 number of times but for different operands. Assume that first time I am executing for 2 plus 3, second time I am executing for 5 plus 7, third program I am executing for some 100 and some 47, and fourth time I am executing for something like say for example something like some different number, something 5 or something like 10. So four different time at a time, four different. I need not to run 4 times. I need not to run for 4 times. So instead of that, I can just call. I can just call one time, but I can substitute it. But I can substitute it 4 times. That means it can be wherever you wanted. Now here after a set of code, one add is called. After a set of code, again add is called. After a set of code, again add is called. So in this way, that is called. But how do the variables get changed? The variables will get changed based on the parameters that we have given. Based on the parameters that we have given. So let us see like that deep into the program. This is what I have just gone again back to your old figure, that is assembler. Old figure, that is assembler. As in then it is a very important to explain, and it is required that help of that figure, because what I have scribbled here, it is also same. I'll just show you my written scribble which I have taken the snapshot. Now if you observe here, it is a source program. It is a source program. I have something a source code which is in high level language, and what it has to be done, it has to generate the executable code. It has to generate my output. Here output. It has to generate my output. To seek output, it has to come, or it has to be processed through all these stages of the through all these stages of the these all are the stages of the system softwares, but these all are the language processing systems. These all are nothing but the different states or different phases of the language processing. Now the first it has to be processed by the compiler. What will be processed by compiler? Whatever the answer, or whatever after clearing the error, or whatever is being pre-processed by macro, or whatever is being this high level language is pre-processed. Whatever the program you have given, it is being pre-processed before a compiler, and that pre-processing is nothing but the macro. That pre-processing is nothing but the macro. After pre-processing, it goes with the compiler. How does it goes in the compiler? You know again very well the story. What are the phases of the compiler? The phases of the compiler, as I once again I want to go back to that here. I will go back to this figure. The phases of the compiler, here somewhere in second module I have explained some front end and back end phases of the compiler. The phases of the front end were the first phase, lexical analysis, that is called as syntax analysis. Lexical analysis or the syntax analysis, lexical analysis or the syntax analysis, and semantic analysis. So these are nothing but the front end, and the back end is nothing but generation of object code and and lastly finally give the executable code, that is, and link it and give the output. So, what were the phases of the compiler? There were analysis phase and synthesis phase. Analysis phase and synthesis phase. So, what a compiler gets on the whole the high level language. What the compiler gets on the whole a high level language. If you observe here, it pre-processes. Before getting into the compiler, a program will be pre-processed by a macro processor. Who is that pre-processing? Who is that pre-processing? But pre-processing is nothing but macro processing. Preprocessor commands that processes the source code. It passes through a compiler. That is it processes before a compiler, before a compiler. And what it gives, if I'll go back to my thing, what it gives, what if you observe here, it is nothing but it gives in the sense the high level language is ready. It is it is being processed now, processed by the macros, and it is being given to the compiler now. Compiler accepts such high level language pre-processing, after pre-processing of the source program. Here I have written that pre-processing is nothing but macro expansion. Means, say for example, fourth number of times in the program I have used add after a set of code. So what is that add? Only once a add function is written, or only once a add is predefined, or only once a add is defined. That defined is expanded in a processing, is expanded by macro processing. That is called as that is called as expansion process, and that is by the macro processor and is given to the compiler. Now compiler, what it does, it does two phases, that is analysis phase and synthesis phase. In analysis phase, lexical analysis, syntax analysis, and semantic analysis. It goes through all the three sets. Lexical analysis I have also told in Lexemac also, and in a compiler also. Lexical analysis, it searches for the lexically whether the so-called class units or so-called units of any particular language belongs to or not, they are tokens or not. Which type of tokens? Either the identifier keyword, identifiers or keyword, or the operators. So such different categories of the tokens it divides. And also what it does, the compiler, it semantically generates the parse tree. Semantically generates the parse tree. That is nothing but semantic analysis. Means whether it is following the syntax or not. Second stage is whether it is following the syntax or not. Once it follows the syntax or not, automatically it generates the meaning. It is nothing but it is ready for generating the low level language, that is assembly level language. It produces or it generates the assembly language. It generates the assembly language. Now this assembly language, which is nothing but an input for the assemblers will take only the assembly language or the machine code language and what they do, this phase was called as this phase what it is this phase was called as the analysis and the synthesis phase and the last part of that is the machine language of the compiler is given to the assembler. Now this assembler, what does it does? For this assembly language, it processes into two algorithms, that is the pass 1 and pass 2. During the pass 1, it gives or it generates the or constructs the three different types of the table based on this machine language or the assembly language. Pass 1, what it does? Pass 1, of course, pass 1 generates the intermediate code. or intermediate representation, and meanwhile it also constructs the symbol table, literal table, and also the literal pole table based on the mnemonic operation or mnemonic code table, based on the mnemonic code table, and it becomes a machine dependent. It becomes a machine dependent means the assemblers are machine dependent. Whether it is a SIC assembler, whether it is a SIX assembler, that means 8086 assembler, or very old versions of the assemblers. It depends based on that. Even in lab, I have shown you two different examples. One is using load and store, LDA and STA. Whereas while explaining theory, I have taken move, move R and move M. So these two respectively, those two are nothing but the machine dependent examples. And because based on them, they have the particular code, machine code. And based on that only the object code is generated. Object code, you know very well that it is generated in the pass-through, and you have also seen how is the pass-through. Pass-through only picks the codes of the pass-one. Pass-one what it is? Pass-one only gives you the which code? Intermediate code. Gives you pass-one gives you what? Intermediate code. And this pass-one is again is made to be processed by pass2, and pass2 generates the exact target code or the object code. So till here, this part was studied, and we have studied full language processings. In language processings, we have seen right from the basics. There were so many problems in design and understanding in coder and giving the uh, project to the developer. So we had a lot of problems in designing part, and there we have come across the execution part, and also we have come across the application domain part. So there we have studied the several consequences what it was appearing in understanding level and in coding level and in executing level execution. So there were the three different domains which were very important to understand to construct any type of a project. So this part was studied, and this will be the fourth unit. Now we are studying macros. What we are studying? Macros. So this was the story. The macro is nothing but they are nothing but the pre-processing statements, and they are the shorthand versions which helps the programmer to write the program. Instead of a lengthy program, we can write in a very short program by writing separately a macro, and macro can also be called in any type of the program wherever it is necessary. So for convenience of the programmer, instead of writing n number of times the same set of code, he can write only once and can be executed. It can be executed. So that is nothing but what? The macro processor. I hope you have understood here what the story I have told. Where was the macro was hidden? Macro is hidden in your source program. The hash statements, the pre-processor statements are nothing but your macro processors. Yes, understood. Ritwij, somebody came now. Yes, understood. Rituja, Prashant, Madhura, Saloni, Aishwarya, Abhishek. Understood. Yes, MI was audible. Do you have any questions? Ashru Bhore, Prashant, Arpana, Apana, Aishwarya, Ahilya. Please answer me. Yes, Pratik, Kruti, Sonia Kagde, Vivita, Preeti Chavan, Gauri, Okay, one. If people are not answering, let me take roll calls. Then again I'll start the class. One, one, two, three,
Yes, ma'am.
four, five, six,
Yes, ma'am.
seven, eight, nine,
Present, ma'am.
10, 11,
Present, ma'am.
12, 13, 14, 15,
Present, ma'am.
16, 17, 18,
Present, ma'am.
19, 20, 21,
Present.
22, 23,
Present, ma'am.
24,
Present.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30, 31, 32,
Present, ma'am.
33,
Present, ma'am.
34,
Yes, ma'am.
35,
Yes, ma'am.
36,
Present, ma'am.
37, 38,
Present, ma'am.
39, 40,
Present, ma'am.
41,
Present, ma'am.
42, 43, 44,
Present, ma'am.
45,
Present, ma'am.
46, 47,
Yes, ma'am.
48, 49,
Present, ma'am.
50, 51,
Ma'am.
52, 53, 54,
Present.
55,
Present.
56, 57, 58,
Present.
59,
Present.
60, 61, 62, 63,
Present, ma'am.
64, 65,
Present.
66, 67, 68, 69,
Present.
70,
Present.
okay, I'll continue again. So I was
Four
filling.
present, ma'am.
Uh, Anybody?
Ma'am, 12.
One,
7 is
ma'am.
present, ma'am.
Hmm.
Ma'am, roll number 7.
Ah.
Ma'am,
Ma'am,
roll
roll
number
number
19.
Okay, is it better again? Shall I take last? What are the absentees? I'll repeat at the last. Again, strength is increased now. I hope again they will come at the end. So, shall I continue for the class? At 15 to 15 minutes before, once again I will tell the absentees list. Again, now if I go to the screen of a teaching, again you people may go. So I would like to continue. I give more importance for teaching. Okay. And these attendance absentees, many are there because without they enter and in between they go off. I hope all these students have went off. So now again you people are telling you are present. And shall I tell at the end absentees list? Yes, many are there. 3 is absent, 4 is absent, 7, 8, then 12, 10, 13, then 5, 20, 22, 8, 20, 38, 30, 31, 37, 39, 42, 43, 48, 50, 53, 55, 56, 57, 62, sorry, 60, 62, 64, 67, 68. So many are there.
Hello, ma'am. 822 has given the present.
Huh.
Ma'am, 55 present है.
Hmm.
7 is
So अभी क्या?
present, ma'am.
तो मैं
Ma'am,
क्या
5
करती?
is present.
हाँ, और एक बार लेती हूँ.
Ma'am,
Ma'am, roll
16
number.
present. Ma'am, 4 present.
Ma'am, 1 is present.
Hmm.
Ma'am, 42 is also present.
Okay, don't worry. To make you alert, I have taken attendance. And in between, your few people are leaving the class. The strength was only 30. So now again 10 more students have been joined. Okay, you can do at the end also. So this was all about the macro. So these macros are in the source program. Are our source program only the preprocessor statements. The preprocessor statements are also called as macros. If you go with the C language, they are also nothing but macros, and they are being processed and they are given to compiler after being processed by the directives, processing directives. Now, very next, how a macro is. A macro, something like this. Sorry, I have written here macro word wrong. Here macro name. So I'll go with the syntax of the last. This is the bookish example. So as per this, you can clearly understand how a macro instruction. These are MSCRO is a keyword. It is a macro instruction. Same like add, sub, mul, like that. This is a macro instruction. Macro is having a instruction like macro keyword and end macro. Soon after the body of the macro, every macro should end. So this is nothing but the definition. This is nothing but the definition of a macro. A definition of a macro is started by the definition of a macro, naming as keyword called as macro. The keyword name macro, again here we start by saying as the macro name. So here in the body of the sequence to be abbreviated, the body of the sequence to be abbreviated, the body of the macro to be abbreviated is like this. Say for example, this is an example only. This is a macro keyword which is nothing but the macro instruction, and the macro instruction follows the name of the macro, that is nothing but the name of the macro can be anything, user defined name of the macro, that is ABC, anything. So here I have taken the assembler add. I have taken because again how a macro look like? A macro look like, because this is again a assembly language. This is being processed by this is again it looks to the assembler an assembly level language, that is which is processed by compiler, but in that inside whenever a macro is defined, how does it does how does it how does it is converting or generating to an assembly program. How does it is generating to an assembly program? But assume that in that macro it is of add. Like say for example, how in C language add is performed by using directly a key operator, that is plus, key operator plus. But at the same time, if you go with the assembly level language, you need to use the mnemonic instruction, that is add. That is nothing but add you need to use. So to perform any high level language, whatever the program is written in that high level language, it has to be, if say for example hash define max 1, what I said, hash define max 1. So hash define is nothing but a preprocessor assembler directive, and it is called as a macro, and max is nothing but a name of the macro. Max is nothing but a name of a macro. And what is defined? It is defined by 1. It is defined by what? 1. So that is nothing but a 1. So whenever max is substituted, it calls that 1. It calls that 1. So in the same way, if we have that macro to be defined, that in this way, assume that this macro is to be defined in this way. Something, a 3 addition is performed. Add something 1 with data, and add 2 with data, and add 3 with data. This is nothing but a definition of a macro. And assume that here the dot, which is nothing but the again set of lines or the codes of the assembly program, and here also codes of the assembly program. Now if you observe in between, the name of the macro is being called here. The name of the macro is being called here. Now this complete is nothing but a program. This complete is nothing but a source program. This completely is nothing but a source program or pre-processed by a macro. And this source program now it goes to a assembler. Sorry, now it goes to a, yes, now it goes to a compiler. Now here it is nothing but Again it is called INCR. This is nothing but a macro name is called here, so that wherever it is called it substitutes this definition, and this part is called as macro expansion. So here you can see how the macro is being getting expansion. Macro expansion by macro processor. Say for example, I am using here call for this WD. WD is name of the macro. WD is name of the macro. Now here store A, store B, store A I am having something like data 1, and store B I am having something like, in B register I am having something like data 2, and here I have some set of code, and this is the macro definition. This is the macro definition, and this definition is named by VD. This is a macro name VD, and WD. This WD is called wherever I want in a program, wherever I want in a program. So how many times it is called in my program? Assume that this is a source program, and then in this source program, how many times it is called? 1, 2, 3. 3 times it is called. So this calling, in another word, we also tell it as macro invocation. So how does it get substituted or get expanded by a macro processor? WD get expanded here. WD, see, this is how 3 times it is getting expanded. WD is getting 3 times expanded, and this in between is nothing but the code. In between we have another set of code for what the program is designed, the source program. So this is how the it is called as the macro expansion, and it is nothing but macro expansion by a macro processor. And this is how once a macro is defined, it can be called wherever you want in the program and any number of times. That is what it is it is told as. That is for you, for programmer it is very convenient. That is, it he can add, or he can add n number of times, or not only one time, wherever it is required for a programmer. And it also resolves writing again and again the same code. Assume that again the same code is used here, again a set of line. Again assume that the same code is used, again some set of line. The same code was required here. So instead of writing the same code again, here also, instead of writing the same code again, it reduces, or it helps for the programmer to write only once, and it can be called wherever it is. Here it was necessary, here it was I wanted, here in this line, here in this line. So according to the logic of the program, it can be framed. So that is called as a macro invocation, and this is nothing but the macro expansion. This is nothing but the macro expansion. So here it was called 3 times. The macro defined was called 3 times. So here it is expanded in that 3 times. Expanded into 3 times. So that is how it is nothing but the same here also the same program. So the macro instruction, macro instruction, body of the macro, which is called 2 times. This is nothing but the macro call. So I have done here one more thing, the same thing. Here also macro can be expanded. Here I have called 2 times. One time strg, one time strg, and here how strg is defined. Strg is the name of the macro, and this is that is the macro is defined in this way: store in this data, store in this b another data, in x again maybe some other data. So this is what a macro was defined, and it was called 2 times. So here 2 times store stda, and store data in b, and store data in 3x, and store data data 1 in A, and store data 2 in B, and store data 3 in X. So in this way, 2 times the macro was being expanded because of this 2 time calling. So this is how macro definition, macro defined or a definition, macro calling or macro call. It is also told as the macro invocation and macro expansion. So these are the 3 main models of the macros. These are the 3 main models of the macro. And I have told you in the previous class also, there are the three types of the parameters. Now here, where can be the parameters? The parameters which I wanted to show in this example, I have not taken, because directly going to the parameters, it may not be able to understand you. So here I have taken macro with the parameter. Macro, the name of the macro is nothing but XYZ. The name of the macro here is nothing but XYZ. And how many parameters were used here? I have used here to one parameter. This is called as the formal parameter. This is called as the formal parameters. And using this one parameter, I have given a variable to the actual parameters. So that is nothing but for adding purpose, I have given one same variable, and for sub also I have given the another the same variable. For add, as in that 2 I have given, 2 is the formal parameter, and this 2 is stored in this register also, and this 2 is also stored in the register B also. It is adding also, and it is adding to the content of the register. It is adding to the content of the register, sorry, subtracting to the content of the register B with 2, and here it is adding to the content of the register A with 2. Whatever the actual parameter is, whatever the formal parameter is getting a value is being passed to this parameters. So this is called parameter passing. This is called parameter passing, and these such parameter passing we have three types. I have told in the last class. One is positional parameters, keyword parameters, and default parameters. What they do, and I have described how the positional parameters, take the same. If say for example there are three positional parameters PQR. For PQR you wanted to give the value A, B, C. You wanted to have for P positional parameters. Here I will write once again as like board ampersand Q, and if you use your comma, then R. So for this, in positional parameters, I may be using here x, y, z, a comma, b comma, c. So using this positional parameter, I am passing my actual values. So a should be given to p only, and b should be given to q only, and c should be given to r only. This is what the positional parameters. How these positional parameters? There is much difference. It is not there between positional and equal to and the keyword and default. Why? Because if you analyze that as default, okay, whatever it wants it can take, and if you analyze that equal to in the sense whatever the keyword value you are mentioning, so it will be assigned in that way. So here A is supposed to go to P, B is supposed to go to Q, and R is supposed to go to C. So these are called as the positional parameters. Suppose if I interchange like B with A, so this becomes again same. Maybe it is understood that P wanted the value of A, but it is getting the value of B. So this depends on a programmer how you are setting the values, how you wanted. Now this is understood like P is assigned by B as per this code, and Q is assigned by A, and R is assigned by C. So in this way, the positional parameters. So it is nothing but we need to be fixed to the value what it wanted, what it has to take, the value of the parameters. Yes, any doubt? So I have told you all about the uh, macro types. We have three macro types, as I said: positional parameters, keyword, and default. And in keyword, all are given the exact values. In keyword parameters, they will get the values in keyword parameter. If you want to give A, it will take A value. If you want to give something like here, I want to use a value of B, here it will take B. Keyword parameters are what you are mentioning, and if you want to give as C, it will take as C. And here accordingly, even you can have swapping, but ampersand P is assigned by A means it will take the same value even if you change this. And in one another type, the another type is nothing but we have default specification parameters. In default specification parameters, what you specify defaultly, I do not to specify anything defaultly. So defaultly whatever is given here in parameter passing, so it will take the same values. Now here I have given value of B, again it will take B, and here I have given the value of C, so it will take this C. But here I have not given anything, so it will take the value of B. So B default parameter what is being assigned during the actual parameters, so those values it will be taken. So another type is there, one more mixed type. Mixed type examples here I will show with pen and paper. Again I will display it on the screen. Okay. So if you want to note it down, what are the macros, macro definitions, and macro expansion we have learnt today, and the types of the macro. And I have told you about how a macro instruction is. A macro itself is an instruction, and macro, that is macro and is also instruction, and is the body of the macro. Macro can be called any n number of times. And where is this macro? This macro is before the processing of the compiler, before the processing of the compiler. That is, it is in the source program itself only. It can be processed by macro. And I have told you about how a macro can be called, and it is nothing but a macro invocation. It is nothing but a macro invocation and macro expansions. So we have seen macro expansion. Macro expansion lead to the macro expansion. During macro expansion, the macro call statements are replaced by a sequence of assembly statements. And this story I have just narrated using my own script. That is the first slide which I have shown you. The same story which I have narrated here using by scribbling the pen on the paper. So that is the same which I wanted to show using this figure. Okay, a program with a macro definition and calls. So it is pre-processed. Macro is pre-processed and is given to the compiler. compiler will give you the assembly language. That compiler part is not taken here. It will give you the assembly language, that is nothing but machine understandable language, and that machine understandable language is taken as the input by the assembler. Assembler generates, you know very well that is the target program of the object code. Target program of the object code. And here is also one more example, but that example is of using set. Yes, all of you, are you there? Yes, have you understood? Any doubt? Now, can I ask what is a macro? Yes. What is a macro? Macro replaces each macro instruction with corresponding group of source language statement. With corresponding group of source language statement. And why macros are important? Macros are important because it helps for the programmer, instead of writing big program and instead of writing multiple times, if he may be requiring in that program, so only once it can be written, macro can be written, and it can be called those many number of times whatever is been required by the programmer. Yes, any doubts? Hello? I told one question no in the previous class. Have you solved? I told to generate the object program. Anybody? Yes. What is the location counter for last plus one? Anybody? Yes. Once again, I'll process that figure. Yes, can anybody tell? Here, what the location counter will be getting the value? What will be the location counter here? Note down if you want. I am just solving here only. because again writing and displaying on the screen directly answer, it may not work out. Note it down. So here it is. The location counter, it begins at 200, and I have told you how the pass one is done. MOVR and ATR, sorry, ARET, and this goes to the 1. This MOVR is 4, and here it goes to the little table, and time being little table will not have any address location. But here what is the location? The location is 200. And next, how it gets the location 201 means with the help of the length of the instruction. With the help of the length of the instruction. Here the no length is given. Well, you should treat for all the instruction as default case 1 only. In the default case, it should be treated as 1. Yes, anybody? Any doubt in this? Pranesh, Mukund? Pranesh is there? Hello? Yes. Hello, hello, you are there? Okay, I will read out the absentees list. Are you understanding? Here it makes the difference. Okay. Here it will take the object code as 210, and you should tell me how it takes 210. Okay. This one assignment, here the location counter, it will take 210, and here what it will take you should be able to tell. Pranesh Onkar, are you there in the class? Okay, I will read out the absentees list, and
जी
this will
मैडम.
be the final. हाँ प्राणेश, आप ये एग्जाम्पल बोल सकते हैं? इसका पास वन बोलेंगे अभी जो मैंने किया है इधर. इसका पास वन करो, कैसा आता? ये बुकिश एग्जाम्पल है, जस्ट मैंने स्नैप लिया और भेजा इधर. इधर लोकेशन काउंटर क्या आता और इधर लोकेशन काउंटर क्या आता है, इसके बारे में भी मैं बोली बहुत दिन पहले. और इधर आज का क्लास समझ में आया उनका? यस, मैक्रोस बोले तो क्या है, समझ में आया ना? प्राणेश, प्रशांत, योगेश. योगेश आज
जी
नहीं
मैडम
है
है.
शायद. ठीक है, कोई बात नहीं कर रहे. ठीक है, मैं एब्सेंटीज लिस्ट पढ़ूंगी और एक बार, क्योंकि मैं हरी भरी करे तो फिर एब्सेंटीज बच्चों को लॉस हो जाएगा. 3
जी मैडम आए समझ.
जो एब्सेंट. यस, समथिंग यू आर फीलिंग प्राणेश? Okay. Absentees today's are, I will just see here what is the strength. 47, it is same. It is 3. 4.
Roll number 3 present, ma'am.
Okay. 4.
4 present, ma'am.
7. 8.
Present, ma'am. 7 present, ma'am.
Okay. Okay. 7 is also present.
8 is
8 is
present.
also.
Present, ma'am.
Okay. 10. 12.
Present, ma'am. 12
13.
present, ma'am.
13. 19. 19. 20.
20 present, ma'am.
22.
Present, ma'am.
28.
28 present, ma'am.
30. 31. 37. 39. 42. 43. 48.
Ma'am, 4 present.
Yes.
42 is present.
Okay. 43. 48. 50. 53. 55.
Present. 55.
56.
56 present.
57. 60.
58 present, 58, ma'am.
I'm just reading absent. 58 is present. 60. 62. Sorry. Yeah, 62 only. 64. 67.
Present, ma'am.
Present.
68.
65.
नहीं 65 मैंने बोला नहीं 65 प्रेजेंट ही है मैं सिर्फ एब्सेंट
जी
इंग्लिश
शुक्रिया।
का
आई एम सॉरी।
हाँ
जी जी शुक्रिया शुक्रिया, क्षमा कीजिए, पता नहीं था मुझे।
डोंट बी टू फॉर्मल प्राणेश उनका कौन है आप हाँ गुड हिंदी हाँ
नहीं मैडम, ये बारिश की वजह से क्या है, यहाँ पे नेटवर्क नहीं है, इसलिए मुझे पता ही नहीं चला आपने कौन सा नंबर कॉल
ओके
किया।
हाँ हाँ इट्स ओके 68 68 okay so keep solving this example after that again I think we have a class at 3 o'clock
Ma'am, 28.
कितना 28
28.
28 हाँ
मैम 14
मैंने बोला ही नहीं ना 14 एब्सेंट है बोलकर। मैंने सिर्फ एब्सेंटीज लिस्ट पढ़ा। अभी फिर से बोलना क्या जो एब्सेंट है बोलकर। जो एब्सेंट है 10 है 13 है इसी में टाइम जाता है ना। और 19 है 30। अभी बोलो किनको बोलना है। 31 37 59 है 43 48 50 53 57 60 62 64 68 इतने हैं एब्सेंट। Yes, did you heard all these students? Is there anybody present? Okay. Meanwhile, keep solving this, and again we have a class at 3 o'clock. Sorry, 3:15. Na? We have a class at 3:15. So I will display this. Keep solving, and tell me the answer about this. And at 3:15, I will ask about this pass one and pass two. All should tell. I will ask everybody. So if you want to come back and join this, also class is in continue only anyhow. So here I am giving you time to solve you. Again 3:15 I will ask this same question and will proceed further. And there again you can clarify your doubts. Yes, shall we start the class? Hello? Shall we start the class? Yes, if you have any doubts, please share. Tell your friends to join the class. Can you? I was telling about this uh, pass 1 and pass 2, how you do for pass 1 and pass 2. What would be the first code? Can anybody tell? I will tell, please note down. I will tell the code about the pass 1. As the location counter, here the address which is specified at the constant called as 200. As you can start at any whatever the location to be begin by the program you can give, and here a value is selected, a constant that is 200, so that the program begins at the location at 200. So very beginningly, the first line of the assembly program, which is generated by the compiler, this program, which is generated by the compiler. So here MOVR takes the value of opcode value, that is the instruction code or opcode value, as 04, and AREG belongs to the category 1. AREG belongs to the category 1, and here literal 5 is moved onto the literal 5 is moved onto the literal table. And here what the code it takes an pairing of the literal comma l comma, then the value of Yes, am I was audible? I think I was not audible for the second session, as the range was less, and so let me. Have you all done the assignments? Sorry, the lab session. Take this journal. I'll post this journal in your post. Okay. I think the attachment we cannot do. Only for the links we can do. I feel. Okay. I'll post in SP group. Peep into the journal. This was the input for the sixth program. This was it, and I have shown you the Turbo C using Turbo C program 1, program 6, and program 1 which I have done in lab program, that is for token identifiers. Either it is an identifier or a keyword or a operator, and lab 6 is of pass 1 design structure, and lab 7 is of the pass 2 assembler design structure. And pass 2, you know very well that now also whatever I have taught, it is for pass 2. It is for pass 2. Have you all understood? So let me take the attendance. Here, journal I'll post in. Journal will be in group. I told, but I have not posted. So please look into that journal. It helps a lot. And I should post still the notes on assemblers. Notes on assemblers will be posted. One, two, three, 4, 5, 6,
Yes, ma'am.
7, 8, 9, 10,
It is
Present, ma'am.
11,
11 present, ma'am.
1,
11 also present.
12,
Present, ma'am.
13, 14, 15,
Present, ma'am.
16, 17. Yes, Sonali, have you understood? Sonali, Saloni,
Yes, ma'am.
understood?
Yes, ma'am.
13, 14, 15,
Yes, ma'am.
16, 17, 18, 19, 20, 21,
Present, ma'am.
22, 23, 24,
Present.
25,
Present, ma'am.
26,
Present, ma'am.
27, 28,
28.
29.
28.
Yes, ma'am. 29.
Hmm.
30.
Okay, don't be fast. 31, 32,
Present, ma'am.
33, 34, 35, 36, 37, 38.
Present, ma'am.
39. Pooja, have you understood? Pooja. Pooja, have you understood?
Yes, ma'am.
Have you understood? Yes, Pooja, have you understood? 40,
Present, ma'am.
41, 42,
Present, ma'am.
43, 44,
Present, ma'am.
45, 46,
Yes, ma'am.
47,
Yes, ma'am.
48, 49,
Present, ma'am.
50, 51,
Present, ma'am.
52, 53, 54,
Present.
55,
Present.
56, 57, 58,
Present, ma'am.
59, 60, 61, 62, 63, 64, 65,
Present.
66, 67. उनकर समझ में आया?
जी मैडम, आया है समझ में। आप क्या पढ़ा रहे हो? आज तो आया है समझ
इतने दिन नहीं आया। ओके
में। नहीं, इतने दिन नहीं आया, ऐसा नहीं है। इतने दिन नहीं, मतलब आज तो आया है समझ में, मतलब आया है अच्छे से समझ में, ऐसा बोलना चाहता
ओके, हाँ हाँ, ओके। नहीं, कोई भी बात नहीं कर रहा ना, इसलिए आपको बोल। 68, लेकिन फिर भी थोड़ा टफ ही होता है ऑनलाइन समझने में ये सब्जेक्ट, क्योंकि चॉक बोर्ड ऐसा चाहिए हमेशा। एक एक एग्जाम्पल।
45 से 50% समझ में आता है, लेकिन बाकी का
हम्म,
खुद को ही देखना पड़ता है, ऐसे समझ में नहीं आता।
हाँ, लेकिन ये सब्जेक्ट भी थोड़ा वैसे ही है ना, ऑनलाइन में पूरा थोड़ा होता नहीं। बट स्टिल आई एम ट्राई, डायरेक्टली मैं सोल्यूशन आपको रखूँ तो आप लोग सॉल्व नहीं करते। ये प्रोग्राम में डायरेक्टली सोल्यूशन रखना चाहती थी, जैसे आज मैंने किया है। मैंने सोचा आप लोग करेंगे, बट कोई नहीं किया, फिर भी मैंने ही किया। बट आई डिड नॉट यूज something like editing. I just told there only. I hope you all have understood. And if possible, if time permits, एक दिन मैं उसका solution display करूँगी सिर्फ। ओके। लेकिन एल टी ओ आर जी क्या कर रहा है वो तो समझ में आ रहा है ना। एल टी ओ आर जी प्लस है तो उधर एक वैल्यू, एक लोकेशन काउंटर ऐड होता है। जब भी एल टी ओ आर जी देखता है तो असेंबलर उसको समझता है कि मुझे भाई अब सिर्फ लिटल्स देखना है, लिटल्स को एड्रेस करना है, लिटल्स वैल्यूज को। और जब भी ओरिजिन को देखता है तो ओरिजिन जब भी देखता है तो फ्रेश दूसरा मेमोरी एलोकेट करता है, लोकेशन काउंटर दूसरा कंटिन्यूस लोकेशन करता है जब भी ओरिजिन को देखता है। तो जब यही दो डिफरेंसेस रहते हैं, एल टी ओ आर जी तो वो लिटल्स के लिए, और एल टी ओ आर जी उसका वैल्यूज कभी भी डी एस से रिप्रेजेंट करना। That much only, and rest remaining is there is no complication. Whenever L2RG it sees, whenever origin it sees, what happens? तो आज हम
हाँ,
लोग
वहां पे कंफ्यूज, वहां पे मैं द्विधा मनस्थिति में आ गया था। जब मैंने वो ग्रीस फॉर ग्रीस में देखा तो फिर आया समझ में मुझे। फिर आप आज का चित्र से आया, जो आपने वो आज का एग्जाम्पल देखा।
हाँ, जब भी पास वन पास टू बोलने के लिए करना बोलेंगे तो एग्जाम में झट से करना। पास टू में सिर्फ कोड्स डालता है, पास वन में क्लास भी करता है। इम्परेटिव स्टेटमेंट है क्या, वो पूरा पेयरिंग करके इंटरमीडिएट कोड रिप्रेजेंट करना है। पास टू में सिर्फ उसका कोड ही जितना वैलिड है उतना ही कोड डालना उधर अलॉन्ग विद द एड्रेस। वो भी मैंने एक बार दिखाया था। ये पर्टिकुलर एग्जाम्पल को मैंने डिस्प्ले नहीं किया, मैंने सोचा सभी लोग करेंगे। ये बहुत दिन से मैं असाइनमेंट भी दे रही थी, कोई भी नहीं पोस्ट करे इसका आंसर, मुझे पास वन भी नहीं करे, पास टू भी नहीं करे। तो शायद देखेंगे ऐसे ही जब भी टाइम मिलता है तो। अभी भी आपको लैब प्रोग्राम और एक दिखाना है, एक मैक्रोज में। अब तो एक असेंबलर में देखें, असेंबलर पास वन पास टू भी हो, वैसे ही होए जैसे जर्नल भी एक बार देखो, और फर्स्ट प्रोग्राम भी देखें। एक मैक्रोज में एक प्रोग्राम करेंगे, और उसके बाद लिंकर लोड एंड हाउ इट टेक्स, वो भी डिज़ाइन पार्ट देखेंगे। So 69 and 70. Okay. Thank you all.
70 present.
हाँ हाँ, प्रतीक यादव 70 पी है लेकिन लास्ट में आ रहे हैं। आपका नाम क्या है? यादव से होता है। थैंक यू ऑल। टुडे इट वाज अ लॉन्ग सेशन, बट इतना देर बच्चे भी कैसे रह पाए। थैंक यू ऑल। The session closes. I will wind here. Thank you.